Okay, now we want to continue talking about how humans have affected the planet, and so now we want to address pollution. And so the first kind of pollution is the pollution of the land, the water, and the air. And so the first picture shows a garbage dump. The second picture shows raw sewage being dumped into a river. And then the third picture shows smokestacks belching pollution into the air. Well, in the United States, we have made some progress about pollution. So, for example, we put plastic liners underneath our garbage dumps so that catches a lot of the pollutants that comes out of the garbage as it decomposes. We also treat our wastewater before we dump it into our rivers. And then we also put scrubbers on our smokestacks and catalytic converters on our cars to help reduce the amount of emissions that they have. All right, then you have acid rain. So we mentioned that these smokestacks and car exhausts are going to be giving off different kinds of gases. So one kind of gas is going to be carbon dioxide, one is going to be sulfur dioxide, and then one is going to be nitrogen oxides. So these are three things that go into the atmosphere. Now when these gases react with water, the carbon dioxide becomes carbonic acid, the sulfur dioxide becomes sulfuric acid, and then the nitrogen oxides become nitric acid. And they rain back down onto the earth. And so that can cause, for example, tombstones and other things that are made of concrete to slowly dissolve. But more importantly, these acids can change the pH of the soil. And so the plants that live in that soil may not be able to survive if the pH of the water that they're taking in has been disrupted by these acids. So here in Missouri, it's not such a big deal because the rocks here in southern Missouri are made of limestone, and that limestone will neutralize the acids. However, in the Appalachian Mountains of North America, the Appalachians are composed of igneous rocks, so which do not neutralize acids as well. So that means that they have more problems with acid rain in the eastern coast of the United States than we do here in Missouri. Another example of this would be in Germany, the black forests of Germany. A lot of them have died as a result of the pH change in the soil. Okay, then let's talk about the ozone depletion. So ozone is found in the ozone layer. And so you have the surface of the Earth, and then above that is the troposphere, and then above that is the stratosphere, and in the stratosphere is the ozone layer. The ozone layer consists of ozone, which is O3. Now what can happen is that ultraviolet light, UV radiation, can come in and hit the ozone, and then it will break it apart into regular oxygen, the type that you breathe, and another atom of oxygen, which is a radical, which let's not worry about that. Now eventually though, what will happen is the oxygen will recombine with the ozone, or with the O2, to make ozone. And when it does that, it's going to give off infrared light, heat. So ultraviolet, which is bad because it gives you skin cancer and causes cataracts, is going to be converted into heat as a result of the ozone layer. So it protects the Earth from ultraviolet radiation. Now the problem is that back in the 1940s, we used these things that were called CFCs. So CFCs stands for chlorofluorocarbons. And you should know that chlorine and fluorine are very reactive chemicals. Well, these things were used in air conditioners and they were used in aerosol cans. And so let's say that the freon in your air conditioner conked out and you needed to have it replaced. So the technician would come and they'd unscrew the cap, they'd let out all the freon into the atmosphere, they'd pour new freon in to cap it off, and then your air conditioner would work again. So for about 40 years, we were dumping these CFCs into the troposphere. And it took them about 40 years to make their way up into the stratosphere and begin to destroy the ozone. Now, eventually, though, the CFCs will be destroyed in the stratosphere, but for every 1 molecule of CFC, it has the capability of destroying 1 million molecules of ozone. So it wasn't until the 1980s that we realized that we were damaging the ozone layer. And then in the United States, we finally stopped all production of CFCs in like 1995. So this is a problem that, at least in the industrialized world, we have a handle on. So we're not producing these kinds of chemicals anymore. However, they are being produced in other countries that are trying to catch up with the industrialized world, because these chemicals are cheap to produce and they get the job done, but they cause damage to the ozone layer. So eventually we hope that all countries in the world will stop the production of these CFCs, and then the ozone layer will repair itself, but it might take another 40 years for that to happen. Okay, let's take a break, and when we come back, we're going to talk about climate change.